Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 6 Trigonometric Functions Long Question Example 3. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. For the question part A, prove the identity tangent square x minus cotangent square x equals to secant square x minus cosecant square x. For the question part B, solve the equation 2 secant square theta equals to tangent theta plus 5 for the range 0 degree less than equals to theta less than equals to 360 degree. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Let us start to solve the question part A. For the question part A, we need to prove that the left-hand side is actually equals to right-hand side. In this case, tangent square x minus cotangent square x should be equals to secant square x minus cosecant square x. Okay, you can actually choose any of the side to prove. Okay, in this case I'm going to choose the left hand side. Okay, and this left hand side should be same as the right hand side. Okay, in that means when I choose the left hand side, by the time I finish to solve, it should be equals to secant square x minus cosecant square x. Okay, so I hope you understand. So let us start to solve the question part A, and I write down the equation of the left hand side. Okay, in this case, tangent square x minus cotangent square x. Okay, to solve the question part A, we're going to use the basic trigonometric identity. Okay, before moving on into solving the question part A, allow me to show you the quick recap of the basic trigonometric identities, guys. Okay, usually what the student will do is they will try to memorize the basic trigonometric identities, but I don't memorize, guys. Instead, what I do is I just memorize one basic trigonometric identities, and from there I do the derivation. Okay, still don't get it? No problem. Let me show you the working. So from here, this is the basic trigonometric identities, guys, where sine square x plus cos square x you should get equals to 1. Okay, this is the basic, guys. By right, the students should know this formula. Okay, this is consider a simple formula. Okay, guys. So from here, what we're going to do is we're going to divide the whole equation by sine square x. So from here, when you divide the whole equation by sine square x, okay, so from here divide with sine square x. So from here you should get 1 plus cotangent square x is equals to cosecant square x. Okay, so now you have already formed the second basic trigonometric identities in reference to the first one. Okay, so from here we're going to use this first formula, and we're going to come up with the third basic trigonometric identity formula. So how are we going to do that? Okay, in our first step, we've calculated by dividing the whole equation by sine square x. Okay, now what we're going to do is we're going to divide the whole equation by cos square x. Okay, so from here, now you divide the whole equation by cos square x. So from here, you get tangent square x plus with 1, you should get equals to secant square x. Okay, so I hope now you should able to get the concept of the basic trigonometric identities. It is reference to this formula, guys, where sine square x plus cos square x is equals to 1. Okay, so let me box this three formula. And let me just mark an arrow indicates that these two formula originally came from this basic trigonometric identities. Okay. So, okay, now it is clear. What we're going to do now is we're going to use the basic trigonometric identities in order to solve this question. Okay, there is a reason, guys, why I'm doing this. We're going to use this trigonometric identities. Okay, so from here, so tangent square x, okay, it is mentioned in these trigonometric identities. So in order to form tangent square x will be equals to secant square x minus with 1. Okay, so from here your next step working will be equals to secant square x minus with 1, okay, and then minus with, okay, now you see you have a cotangent square x. So cotangent square x, it is in the second basic trigonometric identity. So in order to find cotangent square x will be 1, this 1 you move it over to the right hand side. So from here you get is cosecant square x minus with 1. So from here, okay, minus with in a bracket cosecant square x minus with 1. Okay, for the next step what you're going to do is this negative you're going to times in. So from here you should get secant square x minus 1 minus with cosecant square x plus with 1. Okay, we are very close to our answer. So this negative 1 and positive 1 you can simplify them, which will end up getting 0. So from here your final answer will be secant square x minus cosecant square x. Okay, let me outline the solution for the question part A. Okay, let us proceed our discussion for the question part B, where we need to solve the equation given that 2 secant square theta equals to tangent theta plus with 5 for 0 degree less than equals to theta less than equals to 360 degree. Okay, let us write down the equation given by the question in the working here. Okay, given that 2 secant square theta is equals to tangent theta plus with 5. Okay, so from here what you're going to do is, for this question also we're going to use the basic trigonometric identities, guys. Okay, the first step, whenever you see more than one trigonometric identities in a one set of equation, what you need to do is you need to make them all into one type of trigonometric functions. Okay, since you have two type of trigonometric function, which in this case is secant and tangent, you need to make all the equation either into secant or tangent. Okay, in this case it is better we change all the equation into tangent form, okay, by using this formula, guys. Okay, as you can see here, secant square x is equals to tangent square x plus with 1. Okay, so we're going to apply this formula into the working over here. So from here 2, okay, in a bracket tangent square theta plus with 1 equals to tangent theta plus with 5. Okay, so this 2 you can times in. So from here you should get 2 tangent square theta plus with 2 equals to tangent theta plus with 5. Okay, so from here what you're going to do is this tangent theta and 5 you're going to move it to the left hand side. Okay, so from here you should get 2 tangent square theta minus tangent theta minus 3 equals to 0. Okay, this trigonometric function, it looks similar to a quadratic equation, guys. Okay, so what you're going to do is we're going to treat this trigonometric function like a quadratic equation. Okay, so from here what you're going to do is we're going to perform the factorization. So let us factorize this trigonometric function. So when you perform the factorization, you should get 2 tangent theta minus 3, okay, and then in the bracket tangent theta plus with 1, okay, you should get equals to 0. Okay, up until this step it is very simple, guys. Okay, but upon this step onwards you need to be very careful. Okay, why am I saying so? You need to keep an eye on the range, guys. Okay, remember that they give the range from 0 degree up to 360 degree. Okay, that means that your final answer must fulfill this range. Okay, so from here we're going to split this into two separate working, and at the end it will combine into one single solution. Okay, so from here take a look at this left hand side. So from here your tangent theta will be equals to 3 over 2. Okay, as for the right hand side, from here you should get your tangent theta is equals to negative 1. Okay, so from here, in order to continue, you need to understand the quadrant concept, guys. Okay, start with the left hand side first. Okay, as you can see here, your tangent theta value gives a positive value. Okay, now you need to recall in which quadrant the tangent gives us a positive value. Okay, actually tangent value gives us a positive value in the first and third quadrant. Okay, so from here we're going to write that in our working here, guys. Tangent is positive in first and third quadrant. Okay, so this is for the left hand side. Now take a look at the right hand side. Okay, as you take a look over here, your tangent value is a negative value. Okay, where tangent theta is equal to negative 1. So now you need to ask yourself, which value of tangent gives us negative? In which quadrant, to be more specific, guys? Okay, in this case will be second and fourth quadrant. Okay, so from here let us write down in the working here. So tangent is negative in second and fourth quadrant. Okay, so from here let us continue with the left hand side now. So from here you calculate this normally, your theta by tangent inverse. So from here you should get your theta is equals to 56.31 degree. Okay, so this answer is representing the first quadrant solution. Okay, remember you need to include the third quadrant solution as well. Okay, so for the third quadrant you need to add your theta angle with 180 degree. Okay, in this case will be 180 degree plus with 56.31 degree. Okay, so you calculate your theta. So from here you get your theta is equals to 56.31 degree and 236.31 degree. Okay, so this is for the left hand side. Okay, now let us focus to the right hand side now. So for the right hand side, okay, you calculate this. Start with the second quadrant. Okay, for the second quadrant, when you calculate the tangent inverse negative 1, okay, you get is negative 45. Okay, but then since you need to consider the second quadrant value, okay, your second quadrant value should be 180 degree minus with 45. Okay, so that is your second quadrant value. Okay, and then continue with the fourth quadrant. Okay, fourth quadrant, your working will be 360 degree minus with 45. Okay, so from here you will get here 2 angle as well, where your theta is equals to 135 degree, okay, and then 315 degree. Okay, so this is for the right hand side. Okay, so from here we can combine the whole solution into one single solution, okay, where you can write here the final answer of theta is equals to 56.31 degree, okay, and then followed by 135 degree, continue with 236.31 degree, okay, and the last angle is 315 degree. So this is your final answer, guys. Okay, let me underline the solution. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I will see you in the next video.